Welcome back, everyone. So in this video, we're going to go through angular impulse. We'll talk about its definition, an equation for it, how we can use different equations for terms that are in the angular impulse equation to then help us manipulate that angular impulse equation. And that will pretty much be the scope of this particular video. In a separate video, I'll take a bit of time and go through different ways angular impulse can be questioned and how they might word those questions, what different diagrams you might see, those kinds of things. Okay, so let's start. To start, we say that angular impulse is a change in angular momentum. Okay, just like when we had with linear momentum, we had this idea of impulse, right? J equals your change in momentum, change in P, which equals force times time. So in other words, if you changed how long of a time that force was applied, you change the object's momentum. Or if you changed how much force there was on the object, you would change the momentum. Similar concept here, but now we're dealing with rotational terms. Okay, so let's get into an equation here. Okay. We start with the idea that angular impulse is a change in angular momentum. Remember, our symbol for angular momentum is the capital L, and we have this symbol delta to represent a change. So it's a change in angular momentum. Okay. We say that's equal to the torque acting on the object times the amount of time that the torque is acting on the object. So we can say that a change in the amount of time will yield a change in angular momentum, and or a change in how much torque there is can change the angular momentum. Right? So obviously a larger force for the same amount of time will cause a greater angular momentum change, or a longer amount of time for that same torque will yield a larger angular momentum change. Okay? Now, we can manipulate this equation in a few different ways depending on how the question's worded and what we may or may not need. So let's do a quick recall. So recall that torque also equals force, a linear force, times that moment arm r times the sine of theta. Okay, so in a way to change your angular momentum, you could change the force, because by changing how much force there is, you're changing the torque. You could change the moment arm, because by changing the moment arm, you're changing your torque, which would change your angular momentum. Or you change the angle between the two, which, to keep it going, will change your torque. Well, if you change your torque, you'll change your angular momentum. Okay. Another thing we can recall is the equation for angular momentum itself, I times omega. So we have angular momentum equals that rotational inertia times angular velocity. Okay? If I change my angular velocity, I'll be changing my momentum. There you go. If I change the rotational inertia, I'll be changing my angular velocity, which can change my angular momentum. Now, it is important to recognize that by saying I'm changing my angular or rotational inertia to change my angular velocity, it's got to be due to an outside force. Otherwise, you're violating the conservation of angular momentum. Right? Remember when we had the system where I'm out here and then I bring my arms in, and by changing my rotational inertia, I'm changing my angular speed, my angular velocity. Well, because of the fact that I am just one system, that doesn't apply to this, because that's my conservation of angular momentum. What would need to happen if I were to change that is, let's say one of my kids came in and they just spun the chair some more. My kid was not part of the original system. That is an outside force creating an outside torque. So make sure that that's not being violated there. Okay? But this is the basics of rotational or angular impulse. Right? Changing your torque by maybe changing one of these things or changing your angular momentum by changing one of these things, which could yield a change in torque, or changing how much time there is, that will tell you how much your angular momentum is changing, which tells you what your angular impulse is. Okay? That is pretty much it for the basis behind angular impulse. Keep an eye out for the next video that talks about how they could ask questions about this. And until then, I'll see you next time.